Hi everyone, my name is Amir and today I will be summarizing a survey on algorithmic recourse, including definitions, formulations, solutions, and prospects. This is Edward. He's 28 years old, has a salary of $75,000, has $25,000 saved in the bank. He's a software engineer and he's single. He's thinking of buying a house. After months of scrupulous savings and many open house viewings, he's finally found his dream home and is ready to place an offer. But first, he must visit the bank. The bank may consult a system such as this one to decide whether or not Edward is granted the loan. Or perhaps one like this. Or maybe even one like this. With the more involved models, these systems typically gain the ability to better model the nuances in the historical data. However, it has sacrificed its interpretability. Naturally, in this setting, some questions arise. The bank may ask itself, what are the most influential features towards the decision? Regulators or governing bodies may ask, is the system acting fairly by relying on sensitive attributes such as age and marital status? And bank customers such as Edward who have been denied the loan may ask, I didn't get the loan, why not? And what should I do to get it the next time I apply? Answering these questions is the concern of interpretable machine learning, or XAI. Among the many definitions of XAI, we adopt the one by Doshi, Velez, and Kim, which is the ability to explain or to present in understandable terms to a human. XAI has a primary goal, which is that explanations should be a means to help a data subject act rather than merely understand. In this regard, one of the primary contributions of our works is to differentiate between what is known as contrastive explanations, which are changes to the input of a black box that would cause a change to the output, and consequential recommendations, which are actions or interventions on causal variables that result in the changes in the features, which then result in the model output being different. With both explanations and recommendations, we answer where somebody needs to get to with their features, as well as how to get there. In this framework, providing recommendations automatically implies an explanation as well. However, the converse does not hold. Later in this survey, we provide formulations of both contrastive explanations and consequential recommendations, and review over 50 papers in the recent years summarizing the optimization objectives and the constraints that are required to formulate the realistic real-world settings. These constraints may include counterfactual constraints, the model constraints, actionability plausibility constraints, and sparsity and diversity constraints. In this table, we also summarize the tools and access and properties of the desired solutions that have been explored. In the final sections of this paper, we ask what are the prospects of the field of algorithmic recourse. The research questions above have primarily focused on one stakeholder, which is the affected individual. However, giving the right of recourse to individuals should not be considered in a vacuum and independently of the effect that providing explanations and recommendations may have on other stakeholders, such as the model deployer and regulators, or in relation to other desirable system properties, such as fairness, security, privacy, and robustness, which are broadly referred to as ethical machine learning. For example, fair prediction does not necessarily imply fair recourse. Robust prediction does not imply robust recourse. Recourse may leak model information or user data, and this is something we would need to correct for. And agents, such as the bank, need not act in the best interest of the user when offering recourse actions among a set of equally good actions. Additionally, there are a number of implicit assumptions made in existing setups, such as the world dynamics are known and do not change, the predictive supervised model is fixed, and the changes only arise due to actions of the individual seeking recourse. All of these are prospective areas of future research. There are a number of take-home messages that we can summarize here. For instance, algorithmic recourse aims to provide answers to two questions. Why was I rejected the loan? And how can I change my situation in order to be offered the loan the next time I apply? In this work, we also emphasize consequential recommendations over contrastive explanations, as the former directly optimizes for the least effort required from the individual to change their situation, and also directly implies a contrastive explanation in the process. We present an overview of the many constraints, including actionability, plausibility, sparsity, and diversity needed to model realistic situations. And we noted that the diversity in the stakeholder needs illustrates a tension between the many desirable system properties. And in order to satisfyingly address all these requirements, we would definitely need to pursue a cross-disciplinary approach, building on the expertise of a panel of technical and social scientists. Now, let's circle back to the initial story of Edward and the bank. This isn't just a story about Edward, and definitely not a story about bank loan approval. There are countless other scenarios where algorithmic systems are making consequential decisions for humans, and we hope that these works are one positive step towards providing agency, recourse, and ultimately trust between humans and machines. Thank you very much.